Welcome to Long Shots. This is an experimental forecast segment we do every couple months using a technique called analog forecasting. And we keep score. We'll show you the scoreboard in just a minute. Exactly what is analog forecasting? Well, we identify a current or recent anomaly in the atmosphere or ocean, go back in time to find other times when that anomaly was in progress. And we ask the question, did it provide any predictive ability for the weather and climate here in Pennsylvania? And if it did, we apply it again right now. If you're still a little bit fuzzy on that, I think as we go through the segment, the cloud of mystery will clarify just a bit on what we mean by analog forecasting. We do have a long shot that we can verify now. The target, back when we made this forecast in early October, was for a warm February. At least 8 of the 10 Pennsylvania climate divisions warmer than average, and we would call it a bullseye if statewide it turned out to be a top 25 warmest February in the past 100 years. The setup happened to be a dry late summer and early fall in the southern lower Mississippi River Valley. This one worked out swimmingly. I'll show you the results in a moment just to remind you what the 10 climate divisions of Pennsylvania look like. Here were the February temperature anomalies in those climate divisions, all well on the positive side, with the rank in each climate division anywhere from the 3rd to the 13th warmest. Statewide turned out to be 6 degrees above average in February, the 4th warmest on record. That means that as we evaluate the accuracy, right on the bullseye. Bessie, safe this time. As we hit the bullseye, that makes 10 long shots that we have verified since April 2022 when we reset the scoreboard the last time. And we're a modest 5 and 5, but 5 of the hits were bullseyes. We're probably getting close to the time when we will reset the scoreboard again. There is still one long shot that we cannot verify, and that is a mild March. At least 8 of the 10 Pennsylvania climate divisions warmer than average in the month that is currently in progress. This is actually going pretty well. I think this one will end up verifying at least 2 degrees Fahrenheit above average statewide would make it a bullseye. And this was based on the idea that we were in a strong to moderate El Nino in the winter, and it was expected to begin to fade. Now, we normally don't do this, but I'm going to use the same sort of analog for a new long shot, and that would be involving the ENSO process, the El Nino-La Nina process. Any climate scientist will tell you that that is one of the most reliable teleconnections or analogs that you can use in forecasting, and I'm going to go back to that particular analog for this new long shot that I will now present. What is El Nino, you ask? Well, you go to the central and eastern tropical Pacific Ocean right near the equator, and you look for unusual warmth, denoted here by the yellows and the oranges. So we are still officially in an El Nino, but you see these little pockets of blue starting to show up in the eastern Pacific. That's a sign that this El Nino is weakening. In other words, the unusual warmth in these waters is beginning to fade. One way to quantify El Nino and La Nina is to look at the ocean water temperatures in this box right here called Nino 3.4 and simply ask the question, are these waters warmer or colder than average? And if we look at a time series of the temperature of those waters, this is actually the anomaly or the departure from average. This is the signature of the El Nino. Temperatures well above average by as much as 2 degrees Celsius, which is about 3.5 degrees Fahrenheit. Those waters warmer than average in recent months. The El Nino peaked, the peak of this graph, back in December, but notice the graph is now coming down. And that tells us that the El Nino is weakening. And in fact, the computer models that we often look to assess where things are going in the tropical Pacific, are we in an El Nino, are we in a La Nina, shows that that descent from El Nino back to average, which would be 0 on this, and even to a weak La Nina, which would put us 0.5 degrees Celsius below average, all happening by later in summer and early fall. And so we're going to use as an analog a strong El Nino during the winter that fades and actually flips and becomes a weak La Nina. In other words, the waters in that box in the Pacific turn cooler than average by later in the summer. So we went back in time and we looked at the archives and asked the question, when did that kind of scenario happen in the past? And we found the 10 best matches or analogs. And those are these years right here. And I've restricted this to only the last 60 years or so to try to keep things recent because the changes are occurring in the climate. So we want to use relatively recent data. And what we found is most of the winters or most of the summers turned out drier than average. Look at all these negative signs. 9 of those 10 analogs had a dry summer. Another way to think about that, if you pick 10 random summers and ask the question, what will precipitation look like? It's kind of the bell curve. There'll be one really wet one really dry one, and the peak will be right in the middle around normal. Well, what about the 10 analogs? Well, notice that we've shifted all the probability from the above to the left, toward drier. And so that's what we're going to go with. That's the signal we're going to use. Our target in this long shot is a drier than average summer in Pennsylvania. That would be June, July, and August. At least 8 of the 10 climate divisions below average. We'll call it a bullseye if it's one of the 25 driest summers on record. And again, the setup here, coming out of a strong El Nino to at least a weak La Nina by late summer. That'll do it for long shots. Back in a moment with more.